So what I actually have here, I'm gonna, just to show you where you can find these things, I'm gonna go into Blackboard and under lecture notes, and the very first PowerPoint that you see where it says section 8.1, all right, so I'm going to use this to start. Now, I may skip through some of the topics that are in this actual lecture note, because here again, this was taken from a previous textbook. Right? All right, so here's some basic terminologies for angles and arcs. So two distinct points, A and B, they determine a line AB, right? And there's a rule that states between any 2 points lies a straight line. A line segment, well, going back to a line extends forever in both directions. So when you see a line, and we don't use this terminology very much, a line is, like, you're going to see these two endpoints. So notice on the ends of this line, I have arrowheads. That alludes to the fact that this line keeps extending forever in both directions. So I'm going to give this point A, I'm going to give this point B. So I can call this line, and you don't see any of this stuff in this course, AB. So like above AB, you're going to see that line with two arrowheads. A line segment, it stops. It has two endpoints. So notice for this line segment, I don't see the two arrowheads, I see two endpoints, right? So this is a line segment. And normally you're going to see it written like this. So all this is actually building up to an angle, right? So we don't actually use these notations in this course, but as we build up to the angle concept, right, it becomes apparent. The portion of the line that starts at A and continues through B, this is called a ray. A ray has one endpoint and it extends forever in the opposite direction. Whenever you write out a ray, you must start it with this endpoint. Okay. Now here's where the angles come in. An angle is two rays that meet at a point. That point is called the vertex. So for an angle, so I'm going to call this ray AB. Right? And then to that, right, I have ray AC, right? So I have two rays. Where they meet, this is called the vertex. So when you actually write out or describe this angle, you can write it out in a couple of ways. I can actually call this angle A. So this funny looking L that you see, that's the mathematical symbol for angle. I can call this angle BAC. I can also call it angle CAB. So I can describe an angle by its vertex alone, or I can describe it by all 3 points. So notice if you describe it by all 3 points, that vertex must lie in the center. Okay. Sometimes you may see a number in some of these things. So I could also call this angle 1. Now, as far as angles are concerned, Let's bring up the slide for a second. We have what are called positive angles and what are called negative angles. All of our angles are considered to be in standard position, right? So we don't really call them rays. We call them an initial side and a terminal side. For an angle in standard position, its initial side is always along the positive x-axis. So for example, so I'm going to draw two rectangular coordinate system. So just as kind of a review for algebra, in the rectangular coordinate system, you have the horizontal axis, which is the x-axis. You have the vertical axis, which is the y-axis. Where these two axes meet, that's called the origin. Okay. So in both of these, right, we have both x and y axes. For positive angles, I'm going to draw my initial side. It's always along the positive x-axis. So all our angles start here. For positive angles, the terminal side is rotated counterclockwise. Right? So this is like the first quadrant, the second quadrant, the third quadrant, the fourth quadrant, right? Q1, Q2, Q3, and Q4. Okay, this is still going to play a part because on some of the questions a little bit later in the course, they'll ask you which quadrant does this angle lie in. All right. For a positive angle, the terminal side is rotated counterclockwise. So like in a lot of these diagrams, you're going to see this little arrow, and this arrow lets you know which way your terminal side is rotated. If you are dealing with positive angles, right, this is 0 degrees. Up here we have 90 degrees. Okay, at this quadrant or quadrantal angle, we have 180 degrees. We have 270 degrees, and then we complete one rotation for 360 degrees. So that means that any angle, bless you, any angle in the second quadrant must lie between 90 degrees and 180 degrees. All right. So this is a positive angle in quadrant 2, right? And it should be in between 90 degrees and 180 degrees. For negative angles, okay, well, I guess before I get to negative angles, I'm going to pull up the all exam formula sheet. And on the next to the last page, you have what is called a unit circle. So on this unit circle, I notice I have their degree measures. So this is 0, 30, 45, 60, 90, 120, 135, 150, 180, all the way to 360. Right? Then I have its rating, even though we haven't talked about ratings, I have its rating equivalent. So 30 degrees is pi over 6 radians. We're going to talk about this pi over 6 in a second. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. Pi is 180 degrees. So if you're trying to convert a radian to a degree measure, right? If you're trying to convert, let's say 5 pi over 6 radians to a degree measure, you could use this chart, right? If it asks you what is 2 pi over 3 as a radian, you can like quickly look here and say, okay, it's 120. Another thing you can do is you simply treat pi as 180 degrees. So 2 times 180 degrees is going to give me what? And then if you divide that by 3, it should give you what? 120. Right? So that's one way you can convert a radian. We're going to talk about that, how you can form it and write it out. But one way is you can use the unit circle. But there's like a catch. Not all the radian measures they give you are going to be in the unit circle. So you might have to figure some of them out. Right? So notice this unit circle only shows you positive angle measures. So then like this stuff that you see here, this unit circle, it has a formula. Bring this up a little bit. And it says x squared plus y squared is equal to 1. So if you think back from algebra, this is just nothing more than the equation of a circle that has a radius of 1. So what you actually see here, these are just the coordinates for this point. So like if my radius is 1, in order for me to get here, I would go over one place and I would stop. In order for me to get here, that's square root of 3 over 2, comma 1/2. The coordinates for this point, pi over 4 is square root of 2 over 2, square root of 2 over 2. So what you see in the black, they're nothing more than the coordinates for that particular angle. Also, on the unit circle, well, we'll get into cosine and sine a little bit later, okay? Because there's something at the top. Well, we'll get into cosine and sine later. But notice that this only shows you positive angle measures. For negative angle measures, things change up a little bit. So this is still 0 degrees. Down below, this is negative 90 degrees. This is negative 180 degrees. This is negative 270 degrees. And then we can complete one negative rotation with negative 360 degrees. So now I'm going to sketch out a negative angle. So this angle is in standard position, so they all start along that positive x-axis. And I'm just going to arbitrarily draw a point in the third quadrant here. This is where the angle rotations come in. So notice on my negative angle, notice how my arrow is rotated. It's rotated clockwise. So taking a look at these two examples, for this first positive angle, I'm going to just kind of guesstimate that at 120 degrees. And then for that negative angle, this should be negative 120 degrees. So notice that positive 120 degrees is in the second quadrant, but negative 120 degrees is in the third quadrant. So here's one thing you may want to do. On your unit circle, you just may want to go in and write 0, negative 90, negative 180, negative 270, and negative 360. And then you may want to go in and write all of these negative equivalents. So like, this is positive 330 degrees. But if this were a negative angle, it would be what? Negative 30. This will be what? Negative 45, negative 60, negative 90, and then so on and so forth. Now, there are a couple problems in that first homework set that deal with negative angles. So just keep in mind that negative angles are rotated clockwise. Question?
In what instance would we use negative angles in real life?
In real life?
Yeah.
I have to think about that. No one's ever asked me before.
I imagine building a building. It's like,
Well, that's the thing about trigonometry. It's mainly used to navigate the universe, because it's all built on what's called a celestial sphere. And then one thing about this unit circle, it says that the radius is 1, but 1 is arbitrary. 1 unit could actually be 3 miles. Right? 1 unit might be 3 centimeters. Since it's a circle with the radius of 1, it can fit any circular type construct. But for now, positive angles are rotated counterclockwise, negative angles are rotated clockwise. So if they actually give you a picture of an angle, be mindful of the rotation. All right, now just some background information about degree measure. It was developed by the Babylonians around 4,000 years ago, and I don't really believe that it's all 100% true that they actually developed it. It divided the circumference of a circle into 360 parts. There are 360 degrees in one complete rotation. So when if someone says, I'm going to make a 360 turn, I'm going to turn my life around 360 degrees, what are they actually doing? They're just going right back to where they started. But if you turn your life around 180 degrees, you go in a different way. All right. So one complete rotation is 360 degrees. An acute angle is between 0 and 90, right? Just some basic geometric terms. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees but less than 180. And a straight angle is exactly 180 degrees. Right. Just some geometric definitions about angles. Okay. Now we're talking about complementary and supplementary angles. And just in a nutshell, if the sum of 2 angles is 90, the angles are complementary. If the sum of 2 angles is 180 degrees, the angles are considered to be supplementary. So if you think about it in a radian aspect, because some of these questions are going to be twofold. They may ask you for the answer in degree. They may ask you for the answer in radians. So if I was looking at this as far as a radian aspect was concerned, 2 angles are complementary if the sum is 90 degrees or pi over 2 radians. And we're going to take a look at an example of that. 2 angles are supplementary if the sum of the 2 angles is pi radians. Because remember that 180 degrees is equal to pi. So let's take a look at an example. That's coterminal. Well, I guess they don't really do that up front. Okay, but nonetheless, let's take a look at this very first problem. It says find first plot a point at the origin, then plot the second point anywhere on the terminal side. So this question assumes that the angle is in standard position, and it assumes that it starts here. You just have to plot the terminal side. So if I were to plot out a 180 degree angle, my initial side would start here. Where will my terminal side go? On the other side. So for this question, I only want to plot the terminal side. So I'm going to place a point at the origin, right? And that should be the graph. And I know that's kind of confusing because you only plot the terminal side and you don't actually see an angle. All you see is a ray. All right, the second question is similar, but it deals with a negative angle.
Can you explain terminal side again?
The initial side would be like an angle has two rays. The initial ray is the starting ray. And that initial ray always is here. The terminal side is the other ray to where that angle actually points. So now this is negative 45 degrees. So what quadrant would negative 45 degrees lie in? Quadrant 4. Because remember, it changes up. For positive angles, this is 0, 90, 180, 270, 360. But for negative angles, this is 0, negative 90 is here, negative 180, negative 270, negative 360. So negative 45 degrees. Right, and if this whole quadrant is 90 degrees, I'm just going to cut that right in the middle. So that's going to be in the fourth quadrant. All right, and that should be our plot. So here again, you don't actually see the whole angle. You're just only plotting the terminal side. Okay. If I scroll down just a little bit, is everybody okay with the supplementary questions? I don't see any radiant stuff in here, which I thought I did. But I'll just take one. Problem number 4, it says indicate whether the angle is acute or obtuse, then find its supplement. So 115 degrees, is that acute or obtuse? Obtuse, right? Obtuse or greater than 90, less than 180. What's its supplement? Okay. So two angles are supplementary if they sum to give you 180, right? Right. So I'm going to just write out an algebraic formula. So x degree plus 115 degrees. If I add these two things up, in order for them to be supplemental, they sum up to be 180, right? That's why I set up an algebraic equation, and now I'm just going to solve it for x. So in order to solve this for x, I would subtract 115 from both sides. So 180 degrees minus 115 degrees, that gives us is it 65? Should be 65. Okay.
So then our answer is 65.
Yeah, the answer should be 65. And I have to flip this thing around. All right, the answer should be 65. Okay, I think those are okay. Those are okay. All right, next we're going to talk about coterminal angles. Okay, and then following along the slides, if we go down a few slides, here are the coterminal angles. You have what are called quadrantal angles. So a quadrantal angle is an angle that's not in a quadrant, it's in between quadrants. The quadrantal angles are 90, 180, 270, 360, so on and so on, right? Okay, because those angles are not in a quadrant, they're in between quadrants. So that's the definition of a quadrantal angle, even though you probably never see that again. Coterminal angles are angles that start in the same spot, they end in the same spot. The only difference is the amount of times that terminal side is being rotated. So here's an example. It says let n be an integer. So keep in mind that an integer is any negative or positive whole number. We have an infinite number of coterminal angles for 60 degrees. All right. So in this example, we're going to give coterminal angles for 60 degrees. Okay, so I'm going to draw out a coordinate system. I have my initial side, and that's always along the positive x-axis. And my terminal side is 60 degrees, right? Just pointed at 60 degrees. How could I find an angle that's coterminal with 60 degrees? So keep in mind that a coterminal angle starts at the same spot, ends at the same spot. So it's possible to take this terminal side and do what to it? Add 360. So if I add 360, 360 plus 60 is what? 420. Right? So 60 degrees is in the first quadrant. 420 degrees is also in the first quadrant, right? We just spun it around twice. It starts and ends in the same spot as 420. I could also find another positive coterminal angle by doing what? I could add another 360. So 420 plus 360 is that 780? Yeah. That's 780. I could also subtract. So I'm actually going to go back to that original 60-degree angle. Instead of adding 360 degrees, I could do what? Subtract 360 degrees, right? So I'm going to take this terminal side, I'm going to rotate it clockwise. So 360 degrees minus 360 degrees is, oops. That's negative 300 degrees, right? is if I take 60 and if I subtract 360, I get negative 300. I can subtract another negative 360 degrees, right? So I get negative 660. And this is going to go on forever and ever and ever, right? So the basic point is, in order to find a coterminal angle, you simply want to add or subtract 360 degrees. So let's take a look at an example. Okay, these two. We're asked to find the smallest possible positive measure coterminal angle for each one of these. I have a 908 degree angle and a negative 75 degree angle. So we want to find the smallest possible positive angle. So we want to find coterminal angles. So I have a 908 degree angle. So first off, which quadrant is a 908 degree angle in? So in order to find that, let's just sketch it out. All right. So I have my coordinate system. This is 0 degrees, 90, 180, 270, bless you, and 360, right? Because we're dealing with positive angles. My initial side starts along that positive x-axis. So if I take my terminal side and if I rotate it one rotation, that's how many degrees? 360, right? If I rotate the terminal side another full rotation, that's how many degrees? Should be 720, right? Because I took the terminal side. So just imagine it's like a terminal side here. Initially, both your initial and your terminal side are located along this position. But when you take the terminal side and rotate it around one full rotation, you get 360. I need 908, so I'm going to spin it around again. So now I'm at what?
720.
If I spin it around another 360, I'm going to overshoot 908, right? So now we're going to take them quadrant by quadrant. So if this is 720, this is going to be what? Since this is 90 degrees, if I add 90 to 720, I get what? 18. I want 908, right? So I need to go a little bit further. So if I were to rotate it here, I'm going to get what? I just got to add 90. So 810 plus 90 is what? 900. So that means 908 is going to be where? In this third quadrant. Okay. So if I rotate it, so is everybody okay with that? A 908 degree angle is in the fourth quadrant. In the third quadrant. Now I need to find an angle, the smallest possible angle that starts in the same spot and ends in the same spot. So I'm simply going to do what? Subtract 360 degrees, right? Until I get the smallest possible angle. So if I were to take 908 degrees, I'm going to subtract 360. I get 548. I'm going to subtract 360 again. I get 188. And if I subtract 360 again, I'm going to get something negative, right? I want the smallest possible positive angle, which means that 908 degrees and 188 degrees are coterminal angles. So the answer here would be 188 degrees. I also want to find, any questions about that one? I also want to find the smallest possible positive angle for negative 75 degrees. Be careful because here we're dealing with a negative angle. So I'm going to draw out my rectangular coordinate system, but I'm going to use negative angles instead of positive. So this is 0 degrees, negative 90, negative 180, negative 270, and back to negative 360. So which quadrant would a negative 75 degree angle lie in? Should be quadrant 4, right? So in order to find the smallest possible positive angle, I'm going to do what to negative 75? I'm going to add 360, right? Negative 75 plus 360 is positive 285 degrees. So negative 75 degrees and 285 degrees are coterminal angles. Now, I believe in some of the homework problems, they use radian measure. Let me see if I can find one. For example, number 11. 11 says find the angle between 0 and 2 pi. So notice they're not using 360 degrees, but 360 degrees is 2 pi. I want to find a coterminal angle for this given angle. Right? Negative 14 pi over 3. Now the first thing I would do, my brain doesn't think very well as far as radians is concerned. I would change this radian measure to a degree. Then I would unwind or do whatever I had to do to get the smallest possible positive angle in a degree. And then I would convert that degree to a radian. Okay, the thing about these problems, if they give you radian degree, they want a radian answer. Okay? So let me show you what I mean by that. That's 14 pi over 3. Find a coterminal angle, and that's the smallest positive. 14 pi over 3. Well, first off, I'm just going to treat pi as 180 degrees. So that's 14 times 180 divided by 3, and I get 840 degrees. Right? So now I'm working with degrees. I took it out of the radian thing for a second to work with degree. So now I'm looking at 840 degrees. So now in order to find the smallest positive possible angle for 840 degrees, I'm going to subtract 360 And could I subtract 360 again? Right. I'm going to subtract 360 again. And then I get 120. If I subtract 360 again, then I go into the negative realm, right? So I got 120 degrees. But if I put in 120 degrees, it's probably going to tell me it's wrong because it wants the answer in radian measure. So tell me how I can convert 120 degrees quickly to radians. I could pull up the unit circle. I got about 1 million windows up. I could pull up the unit circle once I find it. And 120 degrees is how many radians? 2 power 2. So the answer here should be 2 pi over 3.
Could you show us how to do it without the circle? Like if we have like 75 or something. Like,
Say that again?
could we do
Okay,
it
I'm gonna show you
without
that.
the
Okay.
circle?
All right. What a number 12. It says find an angle between 0 and 2 pi in radians, and that has a coterminal angle of -5 pi over 4. So I could pretty much do the same thing, right? I could change -5 pi over 4 to a degree measure. So that's 5. Well, let me make it negative. -5 times 180, right? Because pi is 180 divided by 4. I get -225 degrees. So in order to find the coterminal angle for -225 degrees, I'm going to do what? Add 360. And I get 135 degrees, right? So if I wanted to convert 135 degrees to radians, I can look at my unit circle and I get what? 3 pi over 4. Now, what you're alluding to, there are some radian measures that are not in the unit circle. You got to figure them out. So we're going to talk about that. Now, as far as the radian degree equivalent, here are some more documents in the formula sheet section. There is this unit circle function values chart. It's just like a big old cheat sheet. So it gives you the degree measure, it gives you the radian measure, it gives you the cosine. We haven't talked about this yet, but it gives you the cosine for each angle, the sine, the tangent, the secant, the cosecant, and the cotangent. But for now, you can also find some of these common degree radian equivalents in this chart as well. So this is going to become handy later on when we evaluate trig functions and they ask you what is the cosine of 90 degrees. You can just find 90 degrees, find cosine, and it should be 0.
And that was in where?
That is on the main page. That is in this formula sheet section.
Can we use that on the test?
You can. You can use anything in this formula sheet section on the test. Okay. All right, so next we're going to take a look at converting from radian to degree. All right, now this is kind of convoluted definition for radian, okay? But I'm just going to read it as it is on the chart. It says an angle with this vertex at the center of the circle that intercepts an arc. So mainly you have this angle, right? And this angle is in red. The intercepted arc is this portion where the initial side of your angle and the terminal side of your angle, it forms an arc. And this arc, if you put a ruler on it, is going to measure R. If that arc distance is the same as your radius, that is equivalent to pi radians. That means if your intercepted arc is the same length as your radius, that's the definition of 1 radian. Now, on that unit circle, and I just want to, like on this unit circle, when you say like pi over 6, technically it's pi over 6 radians because radian carries some weight. So here's what I mean by that. If I were to take pi divided by 6, that's not going to give me 30 degrees. That's going to give me like 0.52, which is way off from 30. Right? The word radian is actually, okay, if we kind of take a look at this, it says that 360 degrees is equal to 2 pi radians. They divided both sides by 2. What they did not do is divide both sides by pi. So if I were to take 180 degrees and divide that by pi, I get 57.2. 1 radian is equal, even though you never really see that written anywhere, 1 radian is equal to 57.2 degrees. Which means that if I were to take that pi over 6, which is 0.523 radians, and if I were to multiply that by 57.297, I'm going to get something close to 30. So this is what I mean by that. So I'm going to take pi over 6 I'm going to multiply that by 180 over pi. So I know this may look funny, but I'm actually telling the calculator, give me pi over 6 radians. Now if I hit enter, I'm going to get 30. All right, so that radian is understood to carry 57.3 degrees. So whenever you write out a radian measure, technically you're supposed to write the word radian out in order for that radian to actually equal that degree measure. All right. All right, now if you want to convert from radian to degree and from degree to radian, okay, here's how you would do it mathematically, right, without using the unit circle or that unit circle function of values. So convert between degree and radian. You simply multiply by 180 degrees divided by pi. If you're given a degree measure, and I have that backwards, you want to divide by pi over 180. If you're given a degree measure, and if you want to convert to radian, you multiply by pi over 180. So here's an example. Convert 75 degrees to radians. So I'm going to take 75 degrees. I'm going to multiply that by pi over 180 degrees. So now the 75 over 180, that's going to be reduced down, right? I could use the calculator. Let's see if I put in 75 divided by 180. It gives me a decimal, but I can change that decimal to a fraction. So in order to do that, once you have your decimal, I can hit math. The first option says it'll take what it's given and it will attempt to convert it to a fraction. So I'm going to hit that frac key. I'm going to hit it again and I have 5/12. So from this point, I can just reattach pi. So 75 degrees should equal to 5 pi over 12.
Can you repeat the step you take to get the fraction?
On a calculator?
Yeah.
Okay. I put in,
That's how you got to that list.
I got you. I put in 75 divided by 180. And then when I hit enter, it converts it to a decimal, right? 0.411. In order to convert that decimal to a fraction, you want to hit math. And under math, that first key is the fraction key. So if I hit enter, it's going to take that previous answer. And I'm going to say attempt to convert it to a fraction because sometimes it'll do it and then sometimes it just act crazy. You might have to do it manually. If I hit enter again, notice it gives me 5/12. Okay. So then I just reattach pi, get 5 pi over 12. You can always check this. You can take 5, multiply that by 180, divide it by 12, and you should get 75. But if you're doing this by hand, these are reduced. I mean, this is going to reduce, that's going to reduce to a 5 and a 12. Reduce both of those by 15, I believe. All right, 15 times 5 is 75. 180 divided by 15 is 12. Okay, any questions about that one? Let me just take a look at the homework problems to see. That's code terminal. 75, okay. Okay, now we'll go the other way around. If you want to convert from radian to degree, we multiply by 180 degrees divided by pi. So for example, if you wanted to convert, I think there was one on the thing. Nah, was it? Let's say 15 degrees. Right, because 15 degrees is not in that unit circle. So here's an example. Convert what is 15 degrees? I guess I'm going to make some up. 4 pi over 3. Convert 4 pi over 3 to degree. I can take 4 pi over 3. I can multiply by 180 over pi. But I believe the easiest thing to do here would probably be to just convert pi to 180 and solve it out. But by this technical definition, if I multiply 4 power 3 by 180 over pi, the pi's are going to cancel, right? And then I can multiply my numerators. 4 times 180 is 720. I'm going to keep my 3 in the denominator. If I divide 720 by 3, I should get 240 degrees. All right, so any questions about converting radian to degree? All right, and as I look at the homework problems, I believe we've covered everything except for this one. This number 15. It says find the measure of an angle whose complement is 4 times its measure. Note 2 angles are complements of one another if their measure adds to be 90. So I got to kind of algebraically write this thing out and solve it. So I'm dealing with an unknown angle, right? So I'm going to call that x. This is number 15. I have x degree angle plus, it says if I take 4 times that angle, it should equal to 90. Does that make any sense? So if I go back and read the problem, let me just put all of this together on one page. Do that real quick. Oh, it was 15. 15. All right, here it is, number 15. It says, find the measure of an angle whose complement is 4 times its measure. Okay, and what did I just do? Okay, there it is. All right, so I'm going to write this out as x degrees because that's the angle I don't know. Complement means when you add 2 angles together, you get 90 degrees, right? I don't know my angle. That's unknown. And if I take 4 times that unknown angle, and if I add them together, that should equal to 90. Okay? Does that make any sense? All right, because I'm basically taking the sentence, writing it out in an algebraic equation and solving. So it says find the measure of an angle whose complement is 4 times its measure. So now I'm going to solve it for x. So x degrees plus 4x degrees is what? 5x degrees equal to 90. So how would I solve for x? Divide by 5. So 90 divided by 5 is, oops. Let me write this out. All right, so I'm dividing both sides by 5. There's a little bit of algebra here. And 90 divided by 5 is 18.